Hi students, welcome back. Today we'll discuss Lab 5 taguchi2, which is a continuation of Lab 4 taguchi1. This is also going to be a group assignment, and all the submission requirements as well as the formatting requirements regarding Excel all holds true for this lab compared to all the previous labs. So today we'll talk about this assignment, which I hope that this table somehow rings a bell in your head. If you recall, last time we have constructed a table just like this together, and then this time you're going to add a new column called quality on the right, just like this. So what this is and how it's done is that if you recall last time, we have defined a good quality airplane as one that's flying a far and long distance with a small standard deviation. This still holds true. However, this time we're going to discuss the quality in a more quantitative way. So how we're going to do that is we're going to use this function, this formula right here with a new Excel function called normdist. Normdist is short for normal distribution. A normal distribution is a very fundamental but very, very important concept which you should look forward to learn in probability in the statistics course. I will talk very briefly about what it is and what it does and what it looks like, but for more details you really should either try to look it up online or just try to wait until the probability course talks about it. So usually people refer to a normal distribution curve as a bell curve, and the reason is that it literally looks like a bell. So if you look at this example I've looked up on Google, you'll see that it starts with a very small but long tail. It winds up, peaks, kind of declines down, and then ends with a long and windy tail on the right. It's symmetrical if it's a perfect normal distribution, which will yield a perfect bell curve, but sometimes the tails will be a little shorter, it will be a little asymmetrical, or the peak will be high or low. It really depends on the different properties of this bell curve. But in this case, I think this picture gives a good idea of what a perfect bell curve looks like, and the 68% and 95% indicates the chances of a number that's hitting in this area. So in our case, we have collected 81 data points, which I'm highlighting right here. And if we're asking the question of what is the probability of a plane flying less than 20 feet? We can say that the mean, if you look at it, it's somehow around, I would say 22 or 21. That is the mean. So if the mean is around here, 22, so 20 should be somewhere below here, and then in this region. And then anything that's on the left side of 20, it indicates that the plane has flown under 20 feet. And then the area that's representing it, which I'm trying to shade right here, it's the probability of it flying under 20 feet. So how we're defining the quality right here is that we're using 1 as the perfect quality. If you think about a plane of a perfect quality, it is of quality of 1. If it's of the poorest quality, then the quality is 0. So we use 1 minus the chance or probability of it flying under 20 feet as the quality of the airplane. So that's how we define the quality in this question. And to further explain how to use normdist, if you look at x is our value of interest. As I mentioned before, in this assignment, we're interested in looking how likely, what's the probability of a plane flying under 20 feet, less than or equal to 20 feet. And the mean and standard deviation, we really already have them for each and every plane we manufactured last time, We also noted down the means and standard deviation, so we have them. And then the cumulative is a question. So is this a cumulative distribution or is it a discrete one? So in this case, we assume it to be a smooth curve. A curve consists of infinite numbers of dots. So if you look at this curve right here, how it constructs to be a smooth and cumulative curve is that many dots all connect together to become a smooth line. So I won't go into too much detail of why we're using true, or we're assuming the curve to be cumulative, but we're assuming the curve to be cumulative. So remember, when you're constructing the quality equation, make sure you put true in this case, otherwise it won't calculate correctly. So once you're done with that, just really use the fill handle to drag it down, and you're complete with sheet 1. So moving on, before we move on, if you are curious about what this is all about, how we're using norm dist, and maybe getting an example of it, I found a pretty good one on YouTube. It's called norm.dist by Jeff Davis, if you look it up. So moving on to sheet 2. This one should also look pretty familiar to you. We had everything on the left except for quality, so literally it's just copying what we have just done for the quality column to over here. Just remember that try to have everything of 2 digits. It looks like I have a single digit here, so I'm going to add 1. Yeah, just make sure everything is of 2 decimal places, and you're done with sheet 2. Moving on to sheet 3. If you recall, last time we constructed 4 pivot tables together. And this time we're going to do the same, except that the pivot tables, we're going to add a column of quality to the existing mean and standard deviation. Instead of physically adding a column onto your existing pivot tables, I highly recommend you just go ahead and delete your old pivot table sheet and create a new sheet using a very similar method, which I think in the past students find out that deleting the old one and creating a new sheet is much easier and much better in terms of not messing up with the table format or values or stuff like that. So we're going to do it together. I've already done the weight location, stabilizer, and nose length, so which is leaving wing angle behind, so we're going to do that together. We're clicking on pivot table, and then it asks me to find a range, which I think it's right here. So I'm going to click on sheet 2 and going to select everything but the first column, including the labels and all, and then I will choose a place to place this pivot table. So I want to place it here exactly. So I click on that and say OK. Now, similarly as what we did last time, it is an empty table to start with until I press wing angle. This is what I'm after for this pivot table. I'm going to click on mean, standard deviation, as well as quality. So as soon as I click on that, the numbers are filled in, but not quite correctly. So I'm going to click on the first item in the values and drag it to the left. And now it's looking all right, but not exactly right. If you notice, it says sum of mean distance and sums of everything on top, which we want the averages. So I'll click and select the averages accordingly. If you somehow have no memory of this, I really recommend you go ahead and look at the video that we did last time, because this is really just almost a direct replication of what we did for pivot tables from last time. So I'm going to shrink the decimal places down, and we're going to make sure that the format is the same with the other ones. I'm going to click on the easiest and most simple layout. Border everything as we did above. Make sure the alignment is correct. And the end, it's very critical that I change it to wing angle so your reader will be very clear with what you're doing right here. So after that, you have 4 new pivot tables, and then we're about ready to move on to sheet 4. If you recall, sheet 4 from last time consists of these columns and rows, and this time we're only going to add quality means on the bottom. So I've already added these 3 columns because I've had done them before, but we did this together, so we're going to fill in the last 3 cells together. So what we're really after in here is an average of quality. So I'm going to Control C and select them and fill them in here. You see it's the quality means of wing angle of level 1, 2, and 3, indicating it's D1, D2, and D3's quality means. So that's right. We're going to Control V and fill them in, and you're done with the table on sheet 4. If you recall, last time we had identified the best designs in terms of the greatest mean flying distances and the least variability, or as known as the least standard deviation. And this time we're still going to keep these 2 on, but we're going to give another perspective of which design has the highest quality. So you literally just go ahead and pick out the highest quality of these parameters. I'm not going to go all the way to the right, but you see the gist of it. You're just going to pick the highest quality of all. And you're going to put down the combination here, and you're done with sheet 4. Moving on to the normal curve. So what I have here, I can tell you straight up, this is not a correct bell curve, but I find many students in the past have found themselves in this position, and they raise their hands and ask me why. So here's why, just in case you're going to step into this puddle as well. So what the prompt has asked you to do is to put in the flight distances that we have right here, the 81 data points, into a single column named distance right here, which I have done. So I literally just selected one column, copy and paste it here, and then I selected the next column and I copied and pasted here. So it become one big single column that's named after distance. And then after that, I calculated, this is the probability frequency function, which I won't go into too much detail. Right now, you can just treat it as an fx with this very long and windy equation. You can put that in here as I have indicated. You need 3 very important constants. Those are pi, sigma, and mu. So as we know from Excel 1, Lab 2, pi is 3.14. Of course, sigma and mu have different values, so I need you to select 3 cells to put them in, to locate them. So just like this. And then remember we talked about the cache signs. That is how you fix your selection of a constant in and only in this cell. So after you're done with fixing all your constants in these 3 cells, you can use the fill handle, which is very handy in this case. You just complete the first cell and drag it down. It will do all the work for you. We'll make sure that everything is about, let me make sure everything is 2 decimal places as we have indicated previously. Let's see if it'll work for me. Okay, so now I'm done with the formatting, the alignment looks good, and now I'm going to select everything in these 2 columns, including the labels, and click on charts. If you remember last time we used the marked scatter, and this time we're going to use a smooth scatter like this. So go ahead and click on that. And here comes our messy curve. It is not correct, and the reason why it's not correct is because we have not sorted the distances. To sort them, I select all of them on the first column, only the numbers this time. As you can notice, I didn't select the label, otherwise it won't work. So I'll go ahead and select sort. It has many options, but we'll do ascending. Ascending means that you're going to sort these numbers from the lowest to the highest. After I click on that, a menu asks me whether I wanted to expand the selection. I will say yes, because I not only want to sort the first column, but I also want to sort the second column that's clearly associated with each and every cell on the first column. So I want to sort them together. So I'll go ahead and expand the selection and sort. After I have done with that, you can see my curve has changed to a cleaner one because it's sorted and it's very smooth. I'll expand it and we can change some of the looks of it. Some of the dots are really big and they're kind of overlap together. We're going to make them prettier and easier to identify. So I'll say I would like the diamonds of size 5, and we'll go ahead and change the marker line to a black line. I want everything on the line to look very clear and dark for me. Okay, well, that looks about right. Okay, so once I clicked on that, you can see that my dots are blue, my line is black. So it looks like it has a very clipped tail. It ascends, peaks, it descends, and stops. It somehow reminds you of a curve, right, from the first one. Even though it's not perfect, it has clipped tails and it's not as symmetrical as this one is, but it does have the peak and smooth tails a little bit. So that's because we only have 81 data points. If you had a troop that's throwing the airplanes for you, you will collect 8 million data points, and I almost assure you, you will have a very long and windy tail, almost symmetrical and beautifully perfect bell curve. But in this case, this is good enough, and this is all you need to do for this lab. I will see you next time.